All right, we talk about vanes, knocks, inserts. Now we talk about the shaft itself. This is the most difficult and most technically challenged subject. So anytime you don't understand, stop me, because this is the first time I present this. Okay? Let's talk about the history of arrow shaft. Arrow shaft start with, what's the first arrow shaft usually made of? Bamboo, hollow bamboo. Then you go into wood. Then we do split bamboo to get the best. Then we move into aluminum, carbon aluminum composite, and then we go to carbon. What's the big deal and benefit of each? Bamboo is really one of the straightest, strongest, lightest material out there, no doubt about it. And in the case of wood, you do a spine tester forever and you finally hopefully get about a dozen and a half see the arrow shooting the same. But you know they don't. Temperature change, moisture change, it's all over the place. Then, of course, when you talk to people who really like bamboo, like the Japanese Jandao people, they will use split bamboo. Well, that's about as good as it gets. It's actually better than a lot of things out there. But damn, are they expensive. A good Jandao master split bamboo, we're talking $1,400 to $1,500 a dozen. Well, think about it. Somebody is splitting the bamboo, cutting the outer edge, shave the thing, put 6 pieces of them together, and then wrap it, and then wipe it, and then glue it to get your arrow, and then spine off them to give you a dozen arrows that shoot the same. That's a freaking month. I mean, 2 weeks work. So I'm not sure if you had to work 2 weeks to sell somebody something and support your family, $1,500 is not a lot of money. You only $700 a week. And remember, you come up with your skill, your tools, your material. Now let's talk about the aluminum, carbon, and carbon aluminum, which a lot of talk about. To be frank with you, in the current stage of game, the best arrow are aluminum inside and carbon on the outside. There's no doubt about it. What's the benefit of that class of arrows? Why is that class of arrows so good?
Well, you can build the core of the arrow with the aluminum process and straightness and the tolerance and everything, and then you just wrap and carbon over the top of it.
Make it stiffer and lighter.
Consistent spine.
The linear spine.
Right.
That's the only thing that carbon aluminum out there that would do, is a linear spine. So what's the problem? I mean, a lot of times people say, remember the Beeman days is extruded carbon. It's great stuff. The spine is reasonably linear. What's wrong with it? When it fails, it's catastrophic. And as time goes on, the spine changes. Now, what did people do? Before I go there, let's talk about what is the difference in current technology on carbon. Okay, what carbon tube we currently make most? We make golf clubs, fishing rods. Arrow is a very, very small area in the carbon manufacturing process. The structural carbon is the biggest. If you look at all the drones, all the major construction light, they're all carbon tubing constructions. They're parallel tubing constructions. What are they so special? Why is a lot of fishing rod technology not in arrow? Why is our golf club technology not in arrow? What are the difference? And a lot of people do not know that. And I'm going to emphasize it today. All golf club fishing rods and 90% of the medium-sized arrow are tapered. People say, no, my arrow is straight. I say, are you sure? There's only 3 companies in the world that make arrow that is straight in the inside, which is your gold tip, your black eagle, and also your carbon split bikini. That will be carbon tape. Every arrow is slightly tapered. Some of them more than others. Measure the front and back of every single carbon arrow. There's always 1,000 to 2,000 difference. How come? Because they all thought that when they lower the temperature of the arrow and they pull the mandrels, it's easier. So how do you build? Why is an arrow being parallel so critical? Because we want consistency. The moment when an arrow is tapered, what does that mean? You have a different behavior on every one of them. Now, you remember the nitro stinger arrow or the first ever taper arrow from Lemmy-Class? That's the reason nitro stinger's patent don't mean anything, because 10 years before that, Lemmy-Class already made taper arrows. And when you look at taper arrow, like the nitro stingers, they are fantastic arrows, except one small problem. Not two of them shoot the same. The only company at this current stage of the world able to make a taper that's consistent is made by St. Croix. St. Croix spent over $2.5 million with 3M to come with that machine. And if you want a dozen arrow, prepare to pay $1,200 because you're getting 12 of the St. Croix 5 arrows, tubes to make arrow shafts. Now, why is an arrow shaft being parallel so critical? Because you want the arrow to flex consistently. Now, when we go into, especially on the technology like a golf club, or the only shaft that's similar is structural carbon. Structural carbon is always parallel, always perfectly straight. But guess what? It was not meant to bend. So what is such a big deal about carbon arrows that's different from anything else? Carbon arrow is the only parallel shaft that's meant to bend. Now, when it bends on carbon arrows, just like construction process, which I'll bring you to the next slide. This is what happened. I mean, it's not very clear, but take a closer look. All the linear carbon, that is extruded linear carbon. That is what Beeman makes their own arrow. All the carbon are unidirectional, all the front to back. All right? But then what happens if it breaks? It's catastrophic. Now, this is what gold tip make the arrow. You start with a directional carbon, semi-linear. You offset it angle from layer to layer. What does that mean? That means you offset the angle like this, and then go 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 like this. It's supposed to overlap and cancel out the angle effect, right? The word is supposed. But since they're being angled, the moment when you do multi-layers, there's where the helix and compound helix spine come in. Because no matter what, the layers in between will always have a weak and a soft spot. So the spine or resulting spine itself, this is actually more like this, or this, or this, and this. That's the reason when you got a current arrow, if you spine index it, the moment you cut it, the spine of the arrow will change. The position of the spine is no longer linear. That means if any company tell you, they will pre-index the arrow before they ship it to you. The truth can only be if you don't cut the arrow at all. The moment you cut it, the resulting spine is always removed. Left or right. And I prove to everybody. That's the reason I go, like all the major companies have all my machines. I actually build a spine detection machine in it. So I can tell you what spine the arrow is and which way it's supposed to bend. Because what you're looking for is the resulting bend of a shaft. Now, that being said, what can we do about it? This is what I come up with. It's our flagship 4-layer carbon system. The first, third, and fourth are all true weave carbon at 90 degrees. What does that mean? That means those carbon fiber fours are always this and this. When you cross weave a carbon fiber, 100%, what's the downside of it? No spine straight, because none of the fibers are linear. That means if you build a carbon fiber arrow out of pure weave shaft, you will have an arrow that's 3 times as heavy with no spine. So how do we overcome it? Using a 4K modular carbon and go linear from front to back at 0 degrees. So now all of a sudden, the first, third, and fourth layer is identical. If I want to make this thing 300, 350, 310, I just need to change the second layer. I get exactly what I needed, consistently. Because the first, third, and fourth layer have nothing to do with spine, but to maintain explosion and consistency. So all of a sudden, my resulting spine is linear. But in order to do this, something had to change. A normal arrow with a 5-layer wrap have 10 layers on it. My arrow had 25 to 30 layers. So what changed? Carbon fiber thickness. So I actually designed a carbon fiber that's 1/5 the thickness of normal ones. So when you move from one to the other layer, what happened to the layer to layer gap? The moment you increase the layer, it becomes less important. Very simple. And I got a proprietary process. See, most arrow will come out and you pull the mandrel. Then you grind it in the water tub, centerless grind. After finish, you got 1,000, 3,000, 5,000. I actually designed my own machine. The worst I can get is 1,000s. And not to mention, because of knowing the technology, I've decided not to make the cheap arrow. I can make something like the Carbon Express at 1,000 thickness and make money at $49.95 a dozen. This arrow is good. This specific arrow is going to be $159.95 a dozen. But I'm going to give you similar technology, like people like Goldie Pro 100 and so on, with the 4K wrap that I come up with for $89.95 a dozen. So all my arrows are going to be 1,000s or better. If they are not, simply cut ½ inch of it, you will be. It's only on the end. Because I can't disclose it because I talked to my lawyer. All the process I have is so proprietary. The moment you heard it, you'll change the entire arrow industry. I have to design my own mandrel, my own machine, and my own fiber to accomplish this. So what's the benefit of this? This is a linear carbon arrow with impact resistant, with no torsion. Think about what I just told you. If you don't know me, you think I'm lying. That means you can hit this arrow all day long. It will not crack. If it cracks, it will behave like temper glass. It will come out with small chunks with its fresh cut ends. Because it's stressed to the point it breaks. Because these two wrap, see that? If this third layer wrap were to explode, the third layer wrap is controlled in 45-degree distribution. And the fourth layer is holding it at 0 and 90-degree distribution. How is it going to splinter? It couldn't. Now, this is what the part which get real technical. See, as an arrow bends, the outside fiber is pushing this way, and the inside fiber is pushing this way. Am I right? What is the shape of the arrow at this point? Is it this? Or is it this? Or is it this? Is it a circle, an elliptical, or off egg? Answer is that you do not know.
Yeah.
The construction dictates it. See, a lot of people, 90% of the time, this is what we expected. But it's not. I will prove to you later, every single arrow have two weakest points, because when you flex it, the high point and low point is not on the linear axis, it's off center. Now you know why when you flex it, when you shoot an arrow, it's an elliptical spin. Because the center of the arrow is not in the center, it's off center. That's the reason when they do it, was doing this. It's elliptical spin. That is why all the arrow is spiral spine. This also explains why the spiral spine is. Because as you move the arrow front and backward, this oblong shape keep changing based on the spine area. So in other words, if you look at this circle as a shaft, okay? This is the bending curve for 99.9% of the carbon arrows. It is not what most people thought is this. You actually bend more like this. Which also, if you got my spine machine, you notice that the first spine, you find the weakest spine is at 12 o'clock, you mark it. The second spine usually is at 7 o'clock or as bad as 4 o'clock. How come it's not at 6? Because none of them is at 6. The only one that possible at 6 are aluminum arrows. Which explains a lot why arrows don't fly right. Now, understanding the construction of the arrow, understanding the first curve when you bend it. See, when you bend this arrow, which means that if this arrow have this side of the arrow is going to turn this way, and this side of the arrow is going to turn this way. That's your torsion. That's when people shoot arrows, say, oh, my arrow naturally turn left. How come it's turning left? Because torsion. Because your knot did not force the arrow, the backside not to move. What happened to the front? The entire arrow starts doing this because you compress it. On the aluminum arrow, it will bend like this. It's not bend like this. That's what carbon arrow's inherited problem is. So how do you overcome it? First of all, web it to the point that the torsion are no longer part of the equation. It is a very involved and difficult process. And that's the reason I told you aluminum arrow have an inherited benefit. Because anybody who knows fishing rod will tell you, the weakest point of the rod is the dictating factor of the entire rod. That means that I don't care how strong your handle is, your tip is how you spine your rods. If your rod do not follow your tip, you don't have a fishing rod. That means if you build a fishing rod, the spine is not linear and all the way through, you can't cast the rod correctly and your fly line will go all over the place. Same thing. But remember, that is based on a tapered shaft. And this is what? Linear. That means every single part exaggerates because there's no front and there's no back. The only thing we have front and back because we put a weight on it to give you the directional control. But that directional control was misunderstood so many times. People put a huge amount of weight in it. Imagine this, you put a huge amount of weight in it, what happened to the tail? It's free fall, isn't it? It starts flapping. Because remember, when you have so much momentum moving forward, the arrow, no matter will flaps. What happened to the tail? It starts flapping like a dead fish. And that's the reason for people who use super heavy FOC arrow. What is the vein they always use? Feather. Why feather? Feather have no directional control. It will collapse. The moment you put directional control like veins on it, the whole thing just go down. That's the reason if you talk to Marcus out of German Kinetics or anybody who use 170 brine and heavier on traditional bow, they will not use veins. They will always use feathers. Because feather gives you the least amount of drag and it will collapse if it go extreme. Just like if you got a feather very extreme at an angle, the feather will collapse, have minimum effect. But if you got a solid vein, what happened? That vein will start directing the shaft. The arrow may go backwards. Think about it, it sounds ridiculous, but the resulting angle may equals to backwards. So you now to keep on increasing the weight of the point. Make you rethink, isn't it? Now imagine if you can control the arrow shaft totally. You control the spine totally. And the arrow will flex only very short while. Just like with arrow vein, concentric points, and so on. What happened to the projectile? The projectile will maintain the energy at a much longer distance. But why is this all of a sudden become necessary? Because I actually got lucky enough to come from the crossbow world. Because as the speed of the arrow increases, as energy increases, we are moving to out of the normal quote-unquote RAM that we learn on the traditional arrow and feather. We are dealing with aerodynamics. We are dealing with harmonics. We are dealing with arrow launch cycles. It's just like all these years everybody's shooting a round ball. The moment you go with a rifle, it changes everything. Arrow vein, in my opinion, is equal to the rifling of an arrow change. And right now with the arrow vein, I have to clean up the rest of the act, which is my insert, my points, and everything I did, I finally come to the conclusion, I tried my best. I have to tackle the shaft itself. Now, knowing the shaft itself, I know that the arrow weave is going to be superbly expensive. So during the process, I say, well, you know, what is the #1 complaint of everybody? Is that if you got something like a decent arrow, you still have the outside splintering. So I'm going to give you sport weave, which is based on my, technically the same as a Goldie Pro Hunter 4-layer, except I'm going to wrap my 4K carbon on the outside and retail it for $89.95. And it'll be 1,000 or better. The whole thing is CNC basis on my design. It's going to be as fast, or you're faster than most. So I think the industry is going to come up with a pretty interesting impact on what I'm doing. Okay, now, understanding the shaft. You see that this force curve right here is one of the biggest deal because most people don't understand when you torque a shaft. See, when you hold a shaft and you twist it, you find out twisting left and twisting right is not the same. That itself should give you a hint how the arrow is supposed to turn. Turn as in circular turn. Because most people test the arrow like this. They never test the arrow like this. The moment you go home and test your arrow, you feel like some arrow turn easier this way and harder this way. So you know the arrow torsion is that side. So if you cut this side, the arrow main shaft will turn to here. Your shaft indexing is now counterclockwise. And most people do not understand, as arrows should get aged, the torsion is what you're facing. The torsion with the spine degradation is what the aging of a shaft means. The higher modular, the less aging you have, the less torsion it has.
So with the arrow vein, arrows that have a high torsion rate, is it, because the arrow veins always spinning to the right?
Clockwise. It doesn't matter.
It's got enough to...
You got enough to overcome. Because see, an arrow, a normal arrow based on the torsion will not exceed half a turn, or maybe up to 2 turns in the first 20 yards.
So you can correct.
The arrow vein 2, even at low speed, you're talking 60 turns in the first 20 yards. 60 over 2 is a non-issue. So, okay, you're not spinning 60, you're shooting 58. How bad does it feel? And then, of course, in the crossbow, in the Oculus, we know that at 60 yards, it's doing 300 revolution every 20 yards with no loss of speed and no sound. That's the big deal. Most people never believe it until they shoot mine. It's just like there's no sound. You can shoot in 30 miles per hour crosswind, the arrow just fly through. And for you guys who have shot it, you notice at any distance, and no matter what, arrow will always hit the target perpendicularly because the arrow descended. Now, this is where the big deal is the off-center spine center. And most people never understand this. That's the reason every arrow when you shoot, when you do a slow motion photography, the arrow actually flex, not centrally, but offset, like that. It's an elliptical spin. And I'm using the arrow veins, the inserts and so on, and the arrow concept to bring the arrow faster into that. So what happens if the arrow don't do that at all to sideward? That's where the arrow wheel come in. I think it's going to be changing quite a lot of thinkings out there. And the best part is that when I was used at the first batch of arrow weave 350, I give to the gentleman in Virginia to shoot the indoor 65, 85, whatever that is. All the guys shooting the same target.
Yeah.
He win it and come back with all 12 arrows and 7 broken necks. You know, because you know those shoots, every arrow touch each other. That pretty much tell you what's going on. I was so thrilled.
That didn't happen to me last year.
No.
Remember, he come back with all the arrows, none of them broke, but with 7 broken necks only. And some veins cut off.
I came back from Reading today with, this weekend. I went with 9 arrows. Wasn't sure if I had enough. I came home with 6.
Very good. You're lucky.
Yeah.
All right, now let's talk about tools. Since you look at the shaft itself.
So when's the anticipated release?
The arrow weave, the squat weave is going to be here next week. The arrow weave is going to be here in 2 weeks from now. On the 246, then the 300, then the 166, then the 315, then the 2764, then I'm on a condition I'll have the 204, and then the 124. I'm not doing half-ass.
No.
I'm doing the whole deal. But at the same time, just like I said, in order to carry Firenock on the arrow, on the squat weave, you can buy anything you want online, but being a dealer, you have to be certified and trained. It means I have to take this class, and you have a 50-mile protection radius. And I will sell to anybody on the arrow weave, but not the squat weave. That is too critical. I need the dealer to understand this before I sell it. I don't want people to just build it and tell me it's no good. Oh, it didn't work for me. No, it worked for you, you just don't know how to put it. So that's the reason the dealer had to be certified and trained. Now then, just like this arrow, before all this is where the tool begins. I have this tool in 2008 Matthew show, and most people don't understand it. That's my arrow vein jig. You see, this, now most, as I said, the Bisonberger will give you between 5 to 17 degrees in accuracy. With the current arrow vein jig, I will guarantee 128 to 256 of a degree per arrow. If you take a closer look, inside this piece is 2 8-5 ceramic ball bearing on a zirconium index. How off can you get? And then look at the entire part. Those are neodymium magnets. I no longer sell this. This is the last 2 pieces after that. The arrow vein adjustable chuck are no longer sold. I am convinced most customers are just not good enough to use it. It is meant for refletching, not for building arrows. It's only meant for refletching. Because you can see that the only way to get it right is just like tools. If you own a set of Craftsman on Snap-on, would you like to replace it with just a crescent wrench? And that's what the whole world tell you. You are better off with a hammer and a crescent wrench than a whole Snap-on tool set when you build arrows. Answer is that you're out of your mind. That's the reason I built the entire chuck set. You notice that? This is for pin mount. I built this for one and only one reason, to handle the old Mako rounds. I do not recommend people using this. This is your pin mount, 166, 202, 235, 246, 285, 300, and 315. Anything beyond that, you use my bushing. Or use pin bushing. Because there's too many arrows above the 315 sizes. They're all specific. And every one of them have pin nuts. So you can use the pin nut with my pin bushing, you're able to control. Why do you need this kind of control? And by the way, that 3 O-ring absolutely do nothing, except if you want to offset it. A lot of people keep on telling me, well, why is the O-ring worn out? The answer to that is that the arrow vein jig is to hold the arrow using this portion of the space. That is a taper space there. Because every single arrow was made on a mandrel that is supposed to be straight within that area. So the moment the arrow touched the mandrel, the metal to internal carbon will grab, will maintain about 15-pound force on it. That is where you're able to control the shaft and the tool. Until the shaft and tool become one, you cannot possibly flush your arrow right. That's the reason I make all these sizes. It's like telling you, you have a 10mm socket, go and fix the car. That's all you got. You and I both know, if the freaking socket is 9, 10 is useless. It's 11, it won't work. But everybody telling you, it's okay to use a 300 size chuck for a 246 size arrow. Because that's what you're doing. Because everybody is using a 2219, which is a 303, or 350s on an OD. But you're using that jig to flush your 166 shaft. Does it even sound right? And then you look at the front of the shaft, which is right here. You notice all arrow vein jig have 2 levels theoretically? Why 2 levels? Why levels to start with? Every single Bisonberger, the vein is like this, right? What glue are they using back then? Yes. What's the viscosity of flux bond? About 20,000. What do we use today? Cyanide acrylate. What's the diameter? We're talking 200 or 600 diameter. But 600 centipoint compared to 10,000 or 20,000 centipoint. The viscosity is literally thousands of times different. When you flex point, when you put on the glue, the thickness of that glue is how many? We're not talking counting how many molecules. We're counting literally in the millimeters. But the moment you start acrylate in the 600 centipoint, you are dealing with 6 molecules thick of glue. Now you know why. If you use this jig with my veins, you are putting 0.03 grain of glue per vein, compared to 0.8 or 1.5. That's per vein. Now if you take a closer look at this, that means at that moment, I will quarter level this jig first, right? So what if I use a pin nut? The diameter shaft and the hook are no longer level. Am I right? Because you don't know what the hook can be. So the only way to guarantee this shaft is perfectly level is put a secondary level on it and using the adjustable to raise or lower it until the entire shaft is level. Because you are dealing with a 600 center point glue, that you want evenly spread the entire glue over the entire surface. Otherwise, the moment you do it, the glue will flow down. You've got more glue on the back of the vein compared to the front.
I noticed that with mine. I mean, I've got the bits with the upgrade from Zenith in it, and I've got the clamp I got from you with the brass. And when I get into the X10s or the 1.66s, I have got to do some manipulation.
You had to physically flip the jig forward and then to put it down.
Yeah, and then I gotta do
Like
some
I do it
maneuvering.
to where as I'm laying the jig in, I actually lay it in and roll it forward.
Yeah, but you have not enough glue on top. The only way to do it is that you have to physically flip the Bessenberger jig horizontally, then go down. Otherwise, the glue will come down. There's not enough glue on the front, it's too much glue on the back.
Well, that and just manipulating the angles to get it to land right. It's like, oh my God, these are a pain in the butt. And I
See,
go-
with this,
and I go,
remember,
oh,
all the arrow veins are based on airfoil base. So the feet is 100%, is based on tangent. I don't care what size of the shaft, the tangent is the tangent is the tangent. Now, a lot of people don't understand this, which I'm going to show you this.
super jig.
That one, yeah, super price too.
Where's my clamps? That's okay, I can use this. See this clamp? It took me a long time to decide on the material and design. This is made of solid 303 stainless. It's cast and then machined. Inside there, there's built-in 1/16-inch stainless steel bar. Now what this stick do is that you will now actually use, remember, go all the way to the time that we're talking about the arrow vein.
Yep, so it doesn't squeeze the all over the front.
See that right here? The left and right. See this part here? See this part right here? You actually go into the wind channel. You clamp both sides. And if you take a close look, I actually polished this to be half thousandths, like a quarter thousand straighteners. So when you clamp the vein on top, what are you pushing down? Are you pushing the vein down? What are you actually pushing down?
The boot.
Yes, you're actually pushing this point and this point of the vein. So actually, remember I told you arrow vein was coming at a 3 millimeter degree? The more you point it, you'll do this. So now the glue is in the center and spread. So if you do it correctly, after everything's said and done, there's 6 molecules of glue on it. Think about it. We're talking 0.03 grain of glue per vein. So, how much are we talking about if you actually use this? This is what arrow vein glue looks like. This would do 60 to 80 dozen of arrows for 10 bucks. Most people never believe me until they use it. And the moment you put it on 9 seconds, it puts 680 pounds on pull force. That means me and you combined hang underneath it, it still holds. Now, why is this so critical? Why do I go through all this thing to make this arrow vein jig? And why is this so important for the entire process of the arrow vein and the glue? Because this is your reloading press. This is the only thing that holds the vein correctly to the shaft and guaranteed to be correct. Until you got this point, you cannot guarantee concentrate, because even, okay, you go through a process, you weight your veins. What happened to your glue? How much glue you put in each vein? You say, okay, I'm very correct. Now you're half grain off.
Half grain's half grain.
Exactly. So what happened? You have 0.1 grain and half grain. That's 500% difference. Now people say, we're getting anal here. Have you talked to bench shooter? Which one of them is not anal? If you're not anal, you're just not anal enough. And this is what I'm pushing for. Now, of course, that water level is a design I have. I actually designed my own ball bearing, it's crowned. So the water level actually allows you to rock and give you the perfect form. And then, as you can see, this is where the case will look like. Now, I give you extra other equipment that you needed. There's a full LiCAR 0.25 laser system. So you can use it to realign your vein point first before you refletch. So I will guarantee you 0.5 degree when you refletch. So what you do is that you put the laser on the previous vein, you clean the first vein, you make sure they are within on the same vein. When you click the index, you're within half a degree. Not 1 degree, not 2 degrees, half. If you're careful using a front part, you can move it to closer to a 1/4 degree on the same. Then you can rotate the laser 90 degrees. Now front and back, you can control it. So your reflection become simple. And then since all my Firenock Arrow system is 100% ozone dissolvable, so when you finish, you come to back vein, you fudge it, then you use a cotton cloth, cotton swab, put the cotton swab on where the vein is. You melt the glue away, now you've got a perfect surface to work with. There's no scraping. Because the more you scrape, you're damaging the fiber. So we chemically remove the Firenock Arrow. Now you've got a clean surface to work with, and you use a laser to guide it back. I know it's a lot of work, but you're talking an arrow that you spend so much time building. Why not take more time rebuilding it? And, okay, now, that is on the jig itself. Now we're talking about before you put the jig on the shaft in building process. You now have to think about the APS. This is the APS I come up with. That's an option over option. On any arrow under 400 spine, 2 blocks is all you need. But anything under 400 spine, you need a third. Anything over 700 spine, you need 4 blocks because the shaft is too soft. At the same time, when you start doing free spinning, if you don't have a pine reach, get one. But the pine reach don't let you force it because the pine reach is too soft. So I give you the super spinner. Those are 3 bearings sitting on an aluminum reel with the O-ring on the side. People say, can't you just use the APS to spin? I say it's all mechanical advantage. If you use a 2 tiny ball bearing, the ball ring can turn 1.5 turn before the 2764 turn once. The moment I increase the size, this will turn once, the shaft turn 5 times already. Pure mechanical advantage. And this is the 6 different things you can do. You square your arrow end first. Because when you cut, you know your arrow end is always off. Then for some of the junk inserts, after you glue the insert, now this is part, to be truth to you, if anybody needs to square the inserts, that means the insert is not going right. If a lot of people say, let's go and square the insert, which means that your insert is actually offset. Why would the insert not be straight to start with? But let's just go there and say, okay, we will let you square the insert. In what times you're going to square the insert? When the field point or broadhead bent and cause indentation of the insert. That's the only time you need to square it. The next thing you want to do, fudging and resquaring. What does that mean? That happens a lot in competition shooting. Somebody nicked the back of your shaft. If you still want to use it, the first thing you do is sand that portion off. Yes, you're taking 1 or 2 grains off. But if you don't do that, that's going to be the beginning of the cracking point. So you either want to save it or you just want to use new arrows. The next thing about broadhead tuning. Now this is a part that a lot of people don't really do. 99% of broadhead, because without my double O-ring system, the moment you put a broadhead, if you don't spin tune it, you must well not shoot it. I mean, the bad offenders are quite a few other companies, which I shall not name. You already know them. Their furrows are so thin, you put the furrow down in the whole broadhead, you can move about 15,000 left and right. If you don't tune it and you expect to shoot through, you must be magic. And I know I'm not. And of course, the spin checker. A lot of time when you put an arrow up to finish it, you should always put a spinner, at least give you a rough spin to look what's wrong. Because, you know, things always happen. And if anybody knows on the most important time, like competition final and the trophy animal showed up, Murphy's Law is always 10 times more powerful. And finally, outsert installation concentric check, just like I talked about arrow outsert. Most people buy this for that exact reason. They love the outserts, but they can't find a way to concentrate it. Because when the outsert is not concentric, it's like one of my customer, he from the Federal Republic of California. He said that we use all the insert until I check it with your spinner. All my arrows, not even one of them is straight after the insert part. And he did it, and he now understands a big difference. Instead of shooting 20 yards, it's comfortable shooting 55 yards. So, in other words, the moment the customer will want it is that all of a sudden, let me just be frank, with today's technology equipment, if you are not comfortable shooting 50 yards, you have problems. You are telling me for the last 25 years with technology, everything moving, we can barely shoot 20 yards accurately? And we are paying how much more for an arrow and bow? That doesn't even sound right, isn't it? Okay, now, the fun part, PAP system, PAPS, Professional Arrow Preparation System. I will clue you guys if you in the field. This is a system that least people understand it. It is called the first dynamic bend locator. That means you put a shaft on it, within 2 seconds, you're able to find out which direction is shaft going to bend first. Why is that important?
Can you make them all bend the same?
It's the first flex.
First flex?
The first flex. That is also why, I mean, it's like people tell you, I'm going to give you the best tire and the best balanced rim so you can drive your car with the best comfort. Then I come along and say you can buy most of the tire, most of the rim, and then I will spin balance it after you put it together. What do you think is better? Because if you perfectly balance the tire, perfectly balance the rim, does the car drive perfectly? Answer is no. Mercedes-Benz Racing will tell you that that's not the case. Because anytime when you go in a car that goes for 135 miles per hour, you don't balance the tire, you don't balance the rim, you balance the tire on the car. Because you still have the shaft, you still have drum brakes, you still have nuts to balance. Same thing with the arrow. That's the reason when you balance the shaft, you spine locate the shaft, you spin balance it. When you finish it after say 2 or 3 shots, you retest the arrows. Because a lot of arrows were built in memory. There's maybe micro layer separation issues. So if you don't know, do you want to find out when you shoot that final 10x and find out that shaft was not doing well? Because you want to find out before it happens. That's another thing, since I'm here, I will give you another tip. You notice how crisp a fine knot click on the string? When you click on the string, you heard that specific tone. Cling, something like that. I will tell you, this is what you do. When you put the fine knot on a specific arrow on a specific bow, when the first time you do that, close your eyes and remember that tone. The moment you put the fine knot, put the arrow onto the string, and at that day, the tone is not the same, you put the arrow down, pick another one. Because somewhere along the line, there's something changed on the shaft. That's the reason I patented that knot is so critical. Because the knot will give you a complete tone check on your arrow. Nobody ever think of that. Because when you tone check an arrow, what part of the arrow is not checked? Okay, that's exactly my point. None. But you can't tone check an arrow if you got a warm-up bag in it. Because the warm-up bag will give you different results.
Yep, I do the same thing. Click. And then I get a soft click and I go, something happened to that one. Get another one.
Now, this is what the basic PAPS look like. You notice it needs to have 2 different things. Now, I did it so that I can show you what it does. Theoretically, this is put wrong. There's a picture taken by one of my customers, which I just noticed. This side should only face on the outside. And this edge shows the outer edge of the carbon. All right? Why do we do that? You want the absolute consistency. That means you've got an outside, you want to expose of the carbon. You do not care whatever. You do not put it on the knot, you put the exposed part of your carbon, edge to edge, try to be centered. Now you notice unlike other company, my entire thing is slidable. Because not 2 persons shoot the same arrow all the time. So what you're looking for is the entire shaft's resulting bend. How come I always put in the center? Even is an arrow concept system. Because that's what the arrow going to be. No matter what, the resulting bend is always in the center. Yes, you can shift it somewhere off and left and right, but then you're no longer consistent. So you want to develop a consistent process for all your arrows. Even you have arrow concept. Now by doing so, we are now giving the resulting bend of the shaft. Now why is there a vibration module on the top? That was actually another one of those deals. I'm trying to develop the world's most sensitive automatic systems. The fact is that I don't think anybody want to pay $20,000 for the resulting of it. So I say, well, there's nothing better than a human finger, which is true, but a human finger needs help. I mean, just like when you drop a piece of oil on a piece of table and then slant it, the oil won't move. But when you tap the table, the oil moves. Am I right? So what's changed? I'm actually inserting energy into the shaft. That's the reason right up there is an old Motorola vibration module, like you saw, zzz, zzz. I put one of those in those and put a brass on it. So what it does is that when you press the button, there's energy going through the entire brass into the entire system. What it does is that you lower the initial friction. So when you roll the shaft, you can feel the difference. Now you know why anybody trained, you can now spine a dozen arrows in less than 2 minutes. A lot of people don't believe me. In 2015 IPO in Indiana, one gentleman come to me a dozen arrow that he spent 2 days spine tuning shafts. He said, Dodge, I want to see how good your arrow is. He give me I said, you want me to do it forward or backward? He said, what do you mean? I said, looking at it or backward doing it. He said, it doesn't matter. So I did a whole dozen arrow spine it. And I marked mine. After I finished, I give it back to him. Damn you. I spent 2 days doing the same thing you do in 2 minutes. And I do it in front of Black Eagle with Jason Wilkins and Dan McCarthy. I do it backwards. And it's right on. So they can't say I'm just making this up. I also do that in 2000, for Dan McCarthy, I did in 2016 IBO Indiana. So you can verify that. Now let's look at it. Why is this ball bearing so critical? A lot of people build their own spine tester, so-called. But let's take a look at what spine tester really does. What are you trying to do? A lot of people are looking for the high and low spot of a spine. We just learned that the high and low spot don't mean anything. Because the high and low spot only mean is the imperfection of the grinding process. What are you really looking for? It's the lowest possible bend point. Now a lot of people put on it and they try to turn it. I say, okay, this is the highest point. You are just looking at the imperfection of the grinding process of the high. Now you put weight on it, that's a different story. But when you put a weight on it, like a typical, how many contact points do you actually have when you do that? The typical machine nowadays have no less than 1, 2, 3, 4, 1, 2, 4 plus infinity. You got 2 hooks and you got 4 ball bearings. What are the ball bearings profile? They are flat. So the moment you bend, what part of the ball bearing is touching it? The edge of that ball bearing, right on the flat edge. So you are just increasing the friction way upscale, and you are not using the curve. Now if you take a closer look at this ball bearing, notice crown? Second, you notice there's a screw here, right? Like everybody. No. That screw is the center part. So I'm no longer relying on a screw that go into the ball bearing and then screw there. The center post is the screw. So now you don't have binding issue, because every time you got bobbing a screw in it, the ball bearing turns, you got the binding issue. But if you've got a crown ball bearing, the pressure is always tangent. So you always push down. Even at the angle, it's still pointing down because it's curved. Now you can get perfectly, when you put the pressure on the shaft and you turn it, you can find exactly where the bend point is, the first dynamic bend point. Then I say, how do you know the force is indeed linear? If you look at Arrow APS system, see this 3 part right here? What are those? Those are not bushings. Those are linear bearings. That means you got 3 points on a linear bearing. What's going to happen with the vertical travel? It's within half thousandths, no matter which way you sway it. Now with that means I can feel which way is coming in. So all of a sudden, I got 6 points because I got 6 crown bearing touching it, pushing down. That is the best you can possibly do, mechanically. And finally, this is what most arrow company bought for me, is that when you get a dozen, say dozen arrow, you say 350, What does that mean?
Supposedly the spine.
What does 350 really mean? 350,000 drop based on a 28-inch support at 1.94 pound, 1.92 pound. By the way, you know why it's 1.92 pound? Somebody screwed up. It's supposed to be 2 pound. It was a mistake, but become the standard. So how do you know that? So I actually built this digital module. I actually added the entire system, but unlike others, I got a zero reference. Because you use any single machine, when you put a weight on it, weight is just 0. If you don't have a 0, just like I want to measure to take this table with a 10-foot ruler, where's my 0? You need a starting point. At this current moment, every single spine machine do not have 0 in it. Isn't that funny? That means they always start with something. But what is that something? They don't know. Oh, it's within 5 to 10 thousands. Okay, okay, great. So we have 350, do I have 340 or 360? Now, next thing you ask yourself this question. Now, we already learned the arrow offset spine. Okay, this 1, 2, 3, 4 points. When we say 350, what is that? Is it at this point, this point, this point, this point, or this point? At 350. The answer is that it's supposed to be the average. So if you actually measure an arrow, you find the low point of the arrow, which is this point. Then you do a shake to get your first number. Then you get the second low point, you do a shake. Then you rotate it 90 degrees, do a register. Then rotate 180 degrees, do a register. After you add the 4 numbers together, divided by 4, that is the true spine of the shaft. If somebody tell you can use one measurement and get the true spine of the shaft, he's lying. Because the moment you put 1.92 pounds, you know the arrow is going to go to the lower spine, higher spine, side spine, and opposite spine. That's going to be at least minimum on a 350 spine, 25,000 difference. So say, no, this arrow is not 350, it's 375. It's too low. I say, did you measure it, rotate 180 degrees and see what happened? I say, well, is 180 degrees right? Answer is no, 180 degrees is not right. Because as we already mentioned, carbon shafts are not linear spine. 180 degrees, you are actually pointing at this point. That's not the lowest. It's not the second lowest. It's not the highest. You don't know what you got. Now we go into a little bit further. What happened the arrow is not straight? Maybe we'll ask a question. What does 1,000 straighteners arrow mean? Anybody know? You say, well, this arrow is 1,000 straighteners. What does that mean?
No variance from 1 all the way down through the, you don't get a deviation.
You hope. Yeah, none of the above. This is what it means. Support at 28 inches with the laser pointing down to 360 degrees. It shows 1,000. The arrow is 1,000 straighteners. So what happens if the arrow looks like this? This arrow is 1,000 straighteners. Isn't it? It met the requirement. But let's look at this.
Or if you cut it.
No, because it's 20 inches. So, if
28,
if the arrow is like this,
Yep.
you cut it right here. Isn't that funny? That is what the industry is selling you. You go through a laser at 28 inches. What happens if the arrow is like this? This arrow is 1,000 straighteners. As a matter of fact, you notice those. Because the best thing you can do is get your arrow, put on the table and roll it. That will find those. And can you do something about it? Answer is absolutely. Don't shoot those. And the moment when you use my PAPS system with a digital gauge, now this is actually less. This is more for manufacturer, for like myself. Today's all the machines are pretty good. When they tell you a 350, they're pretty damn good on it. I mean, the old days, we shall unnamed. Some company are 30,000. I mean, that's reason on its sister company, when they say I shoot this so much better than the other one. Yeah, because their 350 is actually a 330. And you shoot better with a 330. Their sister company is supposed to same machine. No, they're not. As a matter of fact, a lot of times when you put the finishing process can actually change the spine of the arrow. While at this, I'll give you a tip. Do you know what is, if you hunt in rain or weather all the time, what is the worst kind of arrow you can shoot? You hunt in heavy rain, late winter, snowing, what is the worst arrow you can shoot?
Carbon. Really?
No, it's not. Nothing to do with the arrow, with the material of the arrow.
Wood said wood, but
Any arrow have camel on it.
really?
Why? What's the big deal? The camel process is a paper-based print process. The moment when you rain on it, that paper hold the water on it. So all of a sudden, your 31-inch arrow can add as much as 50 grains off-center weight.
Grains? Oh, crap. You know, we gotta keep our arrows dry.
Wow. Went a little low.
And not to mention, the arrow start flying sideways. That's the reason when you're hunting rainy days, you know some of the arrow don't fly through. How do you circumvent it? I'll share a tip with you. I learned it from a very good customer of mine. If you want to get yourself a good set of carbon arrow, and turtle wax ice paste it, and then leave it out for a week. Those water will shed right off. You have no such water effect.
Rain-X.
Yes, sir, you got it. Isn't that funny?
50 grains. Oh,
Yeah, most people never believed it.
Well, you know what 50 greens will do
Something
when we're
else to do
tuning
now.
and setting up arrows.
And a lot of people say, first of all, why would you need camel arrows? You never find them anywhere. The camel process was originally done by Goldtip. It's a paper water transfer, it's a paper tapes process. Carbon Express copied it. And
No.
they tried to patent it, but couldn't because Goldtip started it. Well, that pretty much concluded the entire arrow process.